this chapter, which is chapter 6. Um, I repeat, this chapter is important because it forms part of the exam. Um, so you have to understand it, but unfortunately, due to time, you won't be having a situation where you'll be asked, maybe we have a quiz about this chapter and so forth. So what you have to do is to make sure that you do more examples, more examples. Because this chapter is Morning once more. My laptop was acting up. Decided to stop connecting. I didn't know what was the problem, so I had to restart the machine. So thank you for being patient, um, and advise your members that this is the time where you won't afford to miss classes. The reason why I'm saying this is because if you check, when our module is the first module on the exam thing, it's the first module that will be written. So your exam is not far. So if people start decide not to attend classes, they will have serious problems. If you check, in after 2 weeks, you'll be writing exams. After 2 weeks. So let me share the study guide. So this chapter is divided into two sections. The factorial design is divided into two sections. We have a case where we're just dealing with factorial design under CRD, and again from the same section, factorial design, but now with the blocking factors. Factorial design focusing on the CRD, and again it's possible to do factorial design but including the blocks. And after that, the last chapter will be 2 to the power k factorial design. So these are the only, so we have 3 weeks to cover this. And from now on, the Friday classes, Mr. Maswanganyi managed to donate his Friday class now. So from now on, on Fridays, we'll be having double periods. Fridays will be having double period. Like today, I will teach until 10 past 9. And it will help us a lot. So have time to discuss this chapter because it's one of the important chapters. It's one of the important chapters. So let me share the study guide. Oh wait. What I was trying to say is this part here. For chapter 6. If you check chapter 6, most of the things that you'll be doing here, they are related to what we have covered with Mr. Ball. Remember, with Mr. Ball, you managed to do you managed to do block by treatment interaction. So some of the sections here are related to what we have covered before. So introduction is the interaction of in factorial design, where you can have what do you mean by interaction? It means n in r in each cell is greater than 1. That's what we simply mean that r in each and every cell is greater than 1. So this is what will be happening even here. So I will give an example in a case where we have two factors in complete randomized design. Two factors, it means like for example a and b, it means we have factor a and factor b. And again, it doesn't mean that I cannot give you a question where you have three factors. I will give you the question where you have three factors, as long as you understand the idea on what is happening when we're dealing with two factors. You cannot fail to solve a problem where we have three factors. So an interaction when you have two factors is called first order interaction. An interaction where you have only two factors where they intersect, A and B, there's a part where there'll be interaction. That interaction is called first order interaction. So I can give you a question with three factors, but I ask you to test only for second order interaction. You must understand what I mean by that. I will give you an example. I will give you an example now of what I'm talking about. So again, we'll be doing this one, 6.2.2. But this one, I will just explain how it works and we'll also do the example. But for this, it is not that it's time consuming to deal with this two-factor factorial design in a randomized block design case. So I will do we'll do everything, but for the exam, you can take this one out, 6.2.2. But we are going to do it. But just know that when I give you the scope, when I say 6.6, factorial design is part of the scope, you must know that excluding 6.2.2. Same applies to what I said with Latin square design. When I was giving the scope, I said you can take out what? Crossover design. That's what I said. So when I give you the scope, I say chapter 5, where I say Latin, you already know what is excluded under Latin. When you get to chapter 7, again, even on this one, for the exam, you won't do pairwise comparison for chapter 7. But we'll talk about that as we continue. So,
Sir,
yes.
can you please repeat what you said about two interaction with two factors?
I said a lot of things, Christoph. Which one are you talking about now? 6.1.2,
First
6.2.1.
order. You said this first order what?
Oh, I said if you're having only two levels, A and B, it means we have wherever they will intersect, because there will be a time where you'll be testing for A and B, right? So it means when I can ask you that test for the first order interaction, so it means I'm referring to A and B. If I say test for second order interactions, you must know what I'm referring to. But I'll give you an example, my brother. Don't worry about that one. Or before I get, so again, I said we'll also cover this one, but don't worry. When coming to the exam, I want to assess you about this, but we're going to do it. From there, the last section will be 2 to the power k factorial design. Again, with this one, we're talking about the levels of, so this one will only stop at 2 to the power 3, where k is equal to 3. If you can check here, it says 2 to the power k. 2 to the power k means we have can be up to 2 to the power whatever number, but for our module we'll only stop to up to 2 to the power 3. It's possible that we can have 2 to the power 4, 2 to the power 5, up and forth, but for our module we'll stop at 2 to the power 3. So this is the only chapter that is left for our module. So I hope we'll work together, guys. You must focus, pay attention, because if you decide not to come to class, you will regret. You will regret for not taking the classes serious. So what I was saying, Christopher, before I continue with my what I'm simply saying, Christopher, is this one. Let me get my thing. Uh, what I'm saying, Chris, is that I'm looking for that pen. So even the second period is ours, guys. The second period, the one we start at 25 past, is ours. I'm trying to connect this thing here. Okay, it's fine now. Let me know if you are able to see the whiteboard. I'm about to share now. Chris? Chris? Guys, are you still there? Guys, can you hear me?
Yes, sir.
Oh, thank you very much. Oh, so it means I'm calling someone who's no longer here. So what the question that Chris was asking, he was saying, what do I mean by first order interactions? Suppose now we're talking about factors. Let me start from the factors part. Factors. What is happening now? What did I do wrong? What I did here, but this thing does not want to write. All right. So what I was saying, a follow up from what Chris was saying, I was talking about order. So we're talking about factors now. So suppose we have two factors, which it means A and B. This A and B, there will be a situation there where they will be interacting. There will be an interaction effect. So it means there's a situation where we'll be testing for what? For A and B. So these are what? These are the main factors. Main factors because the factor A is not influenced by factor B, isn't it? What is happening under factor B is not influencing factor A. So that is why we call them what? The main factors. I can ask you that why are we saying, what do we mean by main factors? What do you mean by main factors? So you must be able to explain that part. So this one, where they interact, we call this one first. First order interaction. Interaction. Why do we call them first order interaction? Suppose we have three factors. Three factors. We'll have what? A, B, C, right? Obvious, these ones are what? We call these three because we'll be testing this individually, isn't it? So these are what? These are our main factors. But there's a possibility that A can intersect with B, A can intersect with C, B can intersect with C. So these are what? These are first order interaction. Yes?
Sir,
Yes. I'm listening.
Yes, I'm listening. Well, does it mean main factors are independent factors, factor A and B,
Yes.
since they don't influence each other? Yes. Okay,
No,
thank
yes,
you.
they are main factors. What they are not influenced by
Yes,
other
they are main
factors.
factors.
That's
What?
why
They are not influenced by other factors. That's why.
it's different
Are,
from
are
this
they
one now, Mr. Smart.
independent?
It's different from this one. So whatever I'm saying, if you read the introduction from my study guide, you will get all the answers that you are looking for. The first introduction from my study guide addresses what I'm talking about now. What do we mean by main factors? So it means now we have to do what? You have to go back to the drawing board. What do we mean by main factors? Because I like the way Mr. Smanga is asking this question because uh, it reminds me of what happened in the test. I ask you guys, what are the experimental units? Oh, what are the experimental units? Someone write something like this. It's wrong. So are you saying you conducted the experiment with only one person? So this is wrong. And again, this is wrong. Because there you have to be specific. So we're having what? 16 students as our what? As our experimental unit. So I think what the challenge that we're facing now is students they don't they are they enjoy the calculations and theory. And what are you calculating without understanding the theory? That is why sometimes we get to a situation where you don't even know how to conclude. Like what I'm trying to emphasize now about the main factors. What I'm trying to say, Mr. Smanga, is that when you test for, remember, when you are doing this part with Mr. Vo, you are testing for the treatments, even though it was chapter 3, you are testing for the treatments. You are testing for the blocks. When conducting the experiment, obvious there are some things that will be connected. But when coming to testing, we assume that whatever is happening here, it is not influenced by what is happening on B. Whatever is happening on B is not influenced by what is happening on A. But when coming to the interaction now, it's a different story. So to go back to Mr. Christopher, when I was talking about the main effect, first order interaction, and so if I can ask you a question that test for the first order interaction, isn't it? It means, remember your ANOVA table will have A, B, C, A, B, B, C. So now looking at this, let me repeat my statement. I said these three will be main effects. These three will be first order interactions. This one we call it what? second order. So it's very, very important to understand the question. Suppose this is what we are supposed to test. Source of variation. Source of variation. You have to construct, or you are given another table with all these things and total here. And the question is specific that test for, because if you don't understand what you are doing, you'll end up testing for what? Because if you can check here, if I ask you to find F, it means we'll have F for A, F for B, F for C, F for D, A, B, B, C, A, C, and A, B, C. But if you are asked to test for second interaction, which one are you going to test? If I ask you to test for second order interaction, which one are you going to test?
ABC.
Construct an ANOVA table, you construct the ANOVA table, and then when you have the ANOVA table now, my interest is on, I want only to know what is happening only with these three. So I can you can have an ANOVA table like this, but the testing part, I say, can you please test for the main effects? So I'm simply saying, say something about F for A, F for B, and F for C. Don't worry about the other ones. Again, if I say test for the first order interaction, it means I'm simply saying test for only these two. Or I can say test for first order interaction and second order interaction. Or I can combine these two, I say test for the interaction effect. You cannot test for A, B, C because they're not what? There's no interaction happening there. I can say test for the interaction, or test for main effect and first order interaction. I'm simply saying test for this one, exclude the one. So please, when you get to the exam or whatever, understand what is being asked. Don't just calculate, don't just test for the sake of testing. And lastly, I'm trying to summarize what is going to happen in our chapter. These factors, they can come in different levels. You may find that from A, your levels there, small letter A, usually we use small letter A to represent the factor A there. This one will indicate the level. If I say 5 here, so it means under A you have what? A1, A2, A3, A4, A5. Sometimes some books they use A1 as capital letters, and then the main one without what? So it depends which book will be. Also, this 4 and this 5. And B, you may find that B is only having what? 2 levels. 2. So it means we can have what? B1 and B2. So when coming to the data set now, the data set will be looking like this. In a case where we have only 2 factors, suppose A is having 5 levels and B, is having 2 levels. So it means we'll have A. Remember, this one will be what? Factor A and factor B. So it means we have what? B1, B2. Remember, we said B is only having 2 levels, which is B1 and B2. But factor A is having what? A1, A2, A3, A4, A5. So A is having 5 levels. So now our focus is in a case where R is greater than 1. So in each and every cell, you can have what? More than 1 values. So suppose our R is 3. It means here we have 1, 2, 3 in each combination. So you must check all the combinations. So even here it means you have 3 values. So now always our experiments, they will have equal R value, equal number of replications. As I've indicated, this is similar to what we have been doing with Mr. Ball. So if our R is equal to 3 in this case, which means what is our N? Our N, you can find N by saying what? A multiplied by B multiplied by R. A, how many A's do we have? We have A to A5. So in this case, it will be 5 multiplied by 2 multiplied by 3. What is the answer here? Mathematicians? Because we have A is equal to 5, B is 2, R is 3.
It's 30.
It's 30, right?
Yes.
So it means what is under B? How many values? That means we have 15 right here. Our N is our R N for B is what? We have 15 values. Again, here we have 15 values. This side, I think we have 6, 6, 6, 6, 6. So the amount they add to what? Indeed, it's 30 values. So there's nothing much. As long as you understood what you covered with Mr. Bo, when you get to this one, you'll be enjoying, because the only difference is that now we're focusing on what? On factors, not treatment by block. We're focusing on factors. There can be 2 or more. But if there are more than 2, like A, B, C, for this section, the first section, not the 2 to the power k, the first section, if it's 3 factors, I will help you with some of the information, because otherwise you will spend the whole day trying to solve the problem. So now let's go back with this theory. Let's go back to the introduction part of this thing from the study guide. And some of the questions that question that was asked by Mr. Smanga will be solved here. Are you writing something today?
No.
Because if members are not here, unless if they think we are done with the scope. So yeah, what I was saying earlier is that for hours will cover factorial design in the case of CRD. So the example that I was there is in the case of CRD. Again, of design. Conditions are uniform. So here again, we'll be checking what? All the combinations that are happening there. Like what we just did now. Here's an example which is similar to mine. To illustrate a simple factorial design, let's suppose that we wish to study the effect of the combination of levels of vector A and vector B. Then each vector has 2 levels. You see, in this case, each vector has how many levels? It has 2 levels. So it means you can have what? In our case, it's 5, right? So if it's 2 levels, we're saying A is having A1 and A2. B is having what? B1 and B2. But the example that I was giving, my A is having 5 levels. My B is having 2 levels. So that the combinations are as follows. A1, B1. That's the first combination, right? A1, B2. A2, B1. And then the last one is what? A2, B2. There are only 4, right? Because of factor A is having 2 levels and factor B is having 2 levels. So let me do it in the form of a practical. From there, we'll come back to this one. So here we have 4 factor levels, combinations. So let me show you with the one that I was explaining earlier. So that I want you to give me these levels for this problem. So what we're saying there, we're saying, can you see the whiteboard? Oh, that's fine.
Yes.
Factor A, based on that example that is from the study guide. What we're simply saying, we're saying A is having A1 and A2, and factor B is having what? B1 and B2. So let's check the combinations that we're talking about. It means it can be what? A1 and B1, A1 and B2, right? Or it can be A1 and B1, A1 and B2. That's what we're saying, 4 levels, isn't it? So it means we have A1, B1, another one is A1, B2, A2, B1, A2, B2. That is why we have 4. We have 4. This is the class, the example from the study guide. So how many? So it means we have 4 factor level combinations. 4 factor level combinations are the what? Are the treatments. Understand this one, guys. Then these 4 factor level combinations are the treatments. Let me write it down so that these 4 level combinations are the treatments. I will find, guys. Do you follow? Leaders?
Yes, sir.
Yes, sir.
Thank you very much. So it means now I want to modify our ANOVA table now. So it means now, because we have the combinations that can be called what? That can be called the treatments. So now our ANOVA table will be treatments which are formed by what? By the combinations, right? Which are formed by the combinations. And then we'll have A, B, these are the main effects. We'll have interactions, which is AB in this case, and we have error. The reason why I'm emphasizing this is because someone will confuse the factor A and factor B as treatment. No, the treatments are formed by the combinations of by those levels, as I've indicated here. So can you get the same thing here? How many levels will we have for this question here? Can someone tell me how many to have? Or let's get the levels. Let's get the levels for this question. The one way our thing is 5. Let's get the levels. Anyone who want to volunteer? Let's get the levels. Guys, are you there?
Which level, sir?
I want this. I want this information, my brother. Do you understand how I managed to get this information? This one.
Oh,
I'm saying do the same with that one. Now, this one was having only 2 levels, right? A1 and A2. So these are the combinations, right? These are the combinations. I want you to give me the combinations, sorry. Give me the combinations, but now looking at this question. From there, we can move to a practical example now. So we can have what? A1, B1, right? A A2, I assume you're still doing it. Oh, thank you, Kula. Thank you, Kula. So, can you give me the thing, guys? Can you give me how many are we going to have at the end?
10.
10.
10.
I cannot oppose that. You know how you got the 10. So they're saying 10. So the 10 is referred as what? The 10 will be the 10 level combinations are the what? Are the treatments. So now don't be surprised now when we see our ANOVA table with the what? With the part now where you have to test for the treatments. That's where it is coming. Let me check that our ANOVA table. Yes, let me show you what is happening in with our ANOVA table now. Sorry. Because I'm giving an example in a case where we have what? Where we have only 2 factors, right? I said I will explain a case where we have 2 factors, but it's not. That doesn't mean that we will only have 2 factors. We can have 3 factors. We can have 4 factors. So you see, this ANOVA table now is modified. It says you have the treatment, right? This ANOVA table now it says you have the treatment. This treatment was formed by what? Was formed by the combinations. Was formed by the combinations. So you must understand that part. Now you'll be testing for the main effects as indicated here. I think I explained this part. We'll be testing for the main effect. Why do we not call them main effects? The definition is there from the study guide. A by B, first order interaction is A by B. So if we have to do an example, so you have been constructing an ANOVA table for some time. So if I ask you to construct an ANOVA table, given that the thing is not going to be a problem. So suppose we are given this a problem with yes.
Can you please go to the ANOVA table?
The ANOVA.
Yes. So for the interactions,
Ages.
what will be the degree of freedom if we have? Oh, we can never have 3 interactions, ne?
We can never
Have interaction like A, B, C.
you can have no. Let me give you an example, Christopher. It means I have to go back to the whiteboard now. A case where I'm talking about. I'll give you this simple example. You can even have five factors, Chris.
So what's gonna be the degree of freedom?
Let me give you a practical example, Chris. Let me give you a practical example so that we can do this fast. Oh, you're able to see the whiteboard, right, Chris? And other students?
Yes.
So what is happening? What Christopher is saying, suppose we have 3 factors. What your focus is on the degrees of freedom, right, Chris? 3 factors. Where A is 6, B, sorry, B, small letter B is 10, C is, small letter C is 25, right? Right, Christoph? So we're going to have A, B, C, A, B, B, C, A, C, A, B, C. What is the degrees of freedom of A? What is the degrees of freedom of A, Christoph?
6 minus 1.
Which is what?
5.
5. Thank you. What is the degrees of freedom of B?
9.
C?
24.
A by B, it means it's A multiplied by B, right? The value here is what?
Is it gonna, oh yeah, 5 times 9. 45.
I hope you're not using the calculator. Yeah?
45.
45. B and C, write the value here. 9 by 24, right?
216.
216. AC, A and C. So you multiply the
120.
degrees of freedom of A and the degrees of freedom of C.
120.
120. And then A, B, C, it means now you multiply the 3, right? And then write the value here.
1080.
So you understand how.
Okay, yeah, thank
So
you.
the degrees of freedom is not supposed to be an issue. If you know this, right, you cannot fail to what? Find the freedom. Knowing the formula is sometimes it's not necessary. It's not necessary. When you say A multiplied by B, you know the formula for this one is what? The formula for this is A minus 1 to minus, isn't it? So let's continue. So now I was still explaining, guys, that now we have this question from the study guide. We have been constructing an ANOVA table for some time now. So I remember one of the students was here asking about this section. He was preparing for test 2. But in one of my previous question papers, there was this question. He was asking me, how would we solve this? So the person was preparing for the second test. So let's check this one. We're saying in a chemical process, the most important variable that are thought to affect the yield are pressure and temperature. 3 levels of each factors. So you are told that temperature is measured in 3 levels, which means when the temperature is 30, when the temperature is 40, and the pressure is 50. And again, the what? The pressure is also measured in what? In 3 levels. It's clear here, it's 115, 230, and 235. So indeed, all the what? The factors, factor A and factor B, the what? So you can simply say, when you want to solve this problem, it's not a must that you must write factor A, factor B. You can move with the what is given there. You say temperature, you say pressure. When you want to test for the interaction, you say temperature by pressure, and error and total. So based on this question, we have how many? What is our replication per cell? Our replication per cell is 2. So we have 2 values in each cell. So now, if we have to solve this problem, nothing much has changed. It's just now we are moving away from saying SS3, T minus 1, B minus 1, S for blocks, T for, no, we're not using that. Because now we're dealing with factors. Our formulas will change. So to be on the safe side, maybe what we can do, you can say let temperature to be my factor A, and let pressure to be my factor B, so that whenever you use the formulas, you don't get confused, because now the formulas are given the form of what? A and B. Let's check these ones. Oh, sorry. Let's check the formulas that can be used. You see here, you're told that if you want to find SSA, so it means focusing on factor A. Focusing on factor A, the formula will be given by this. If you remember with Mr. Delvaux, when we were finding SS treatment, you were saying 1 over BR summation of I from 1 to T. This was T because we're focusing on the treatment. On top of that summation there, that was T. YI dot squared minus that part there. This thing, you're not seeing it for the first time. So also for factor B, so it means now we're focusing on the columns. The formula again will be given by that. So for this section, you just have to get used to the A and the B, the A and the B. What do we mean by A and B? And when we're dealing with the that chapter of Mr. Delvaux, we're saying SS block by treatment is given by SS model minus SS treatment minus SS block. But in our case now, because we'll be having the what? We'll be having the treatments. We'll be having the treatments that we manage to create from what? From the combinations. We'll be having the treatments that we manage to combine, to get from what? The combinations. So it means values from each cell, after adding them, they will help you to find SS treatment. Previously, the value, when we're dealing with chapter 2, 3, with Mr. Delvaux, the values in each cell for the interaction were helping you to find SS model. But for this chapter, the values from each cell will help you to find SS treatment. So to find SS A by B, it means you must say SS treatment minus SSA minus SSB. So these are the only things that would be, the only things would be, oh, not it's these three main effects, which is A and B, and the interaction, and what, and the treatment. So again, when we're doing these things with Mr. Delvaux, there are some conditions that he gave you when coming to the testing part. Where do you start? What lead you to go to the main effect? So even in this chapter, the same thing happens. When you are dealing with the hypothesis testing, for this section now, for factorial design under CRD, we say you first test for the treatment effect. The one that we're doing with Mr. Delvaux, you are saying you first test for the interaction effect. But for this section, first test for the treatment effect. So let's check what is going to happen. We next test for the interaction. This is only possible if we reject A0 in number 1 above. So you can only test the remaining test provided you have rejected when testing for the treatment. So in other ways, if when testing treatment you didn't reject, there is to test for the other ones. Am I leaders?
Yes, sir.
CH. CH.
Yes, sir.
Yeah, now I can hear you. Earlier, I noticed that you were trying to say something, but I couldn't hear you.
No, my mic was acting up, so I had to get another device to
But
connect with the mic.
now it is fine.
Yes.
Oh, thank you very much. So you wanted to ask something or what? Or because I
No,
noticed that it seems like your mic was on, trying to say something. Did I manage to cover what you wanted to ask?
Yes. You did manage to cover.
Oh,
If
fine.
there's
So
anything else,
if okay, it's fine. So again, guys, sometimes if you don't understand what I'm saying, feel free to ask for clarity. Feel free to ask for clarity, because if you get me wrong, you're going to apply that knowledge and then you find that you do wrong things. So if I say something, I must account to whatever I say. So whatever I say here, please, if you don't understand, let me know. I will try to explain, maybe using a better example. So now I was trying to explain the order of testing. I'm saying you first test for the treatments. Or let me use the ANOVA table. When you test for the treatments, right? And then if you reject when testing for the treatment, you'll move to the interaction. Let me just bold this one. You'll move to the interaction. That is the order. If you fail to reject when testing for the interaction, you'll move to the main effect. So test for the treatment. If you fail to reject when testing for the treatment, there is no need to test for the other information. There's no need to test for the main effects and the interaction. But if you reject when testing for the treatment, you skip the main effects. The main effects, you can only entertain them provided there is no interaction between A and B. If there's an interaction between A and B, you don't test for the main effect. Even if the question says analyze the problem and draw conclusion, that's where now you must what? You must understand your theory. That's where you must understand your theory. And that one might find where I'll give you an example where we can do these things. So now, with that short explanation, can you solve this problem or copy this for a problem? I will solve it together. I will take this thing. Can you please someone? But this is in your study guide, right? Write the values down in case you don't have this information. So when I write it that side, I will only need the sum from each cell. I won't write everything like the way it is written here. So please copy the table. I want to move to the whiteboard. I will do the summary with you guys, and the rest you will do it with your leaders. Can I move to the whiteboard, please? Mtatu. Pretty?
No, sir. Ish. 2 minutes.
Winjan says,
Yeah, Birinjan Tisha.
I'm happy. Are you following? No.
Yes, sir.
It's easy today to communicate with everyone because you are only 10. Novel. Novella?
Sir,
Minjan says,
forgive me, Johnson.
I'm good. Matume, Masocha. Please copy the table, right? Copy the table. Masoja? Mafinya? Mafinya?
Sir,
Beauvoir.
Roboza would be sir.
I saw your email, ne? So we can talk after the class.
Okay.
Okay. Kula, I'm going to the whiteboard now. Kula. Kula. Oh, it seems like she's having network issues. Are you fine, Kula? Kula, are you fine?
Yes.
Thank you very much. CH, come in. Tabela. Let me go to the whiteboard now and then we do that problem together. I understand those, but I don't encourage students to be dodging classes. I understand it's that time of the year where Now, when you look back, you notice that, hey, I didn't collect enough points. And then now you are judged based on the points that you have collected. So, hey, but I'm not encouraging them to be dodging classes like what they're doing. So we have the pressure here. What are the levels for pressure? What are the levels for pressure?
215.
Pressure, right? Yes.
So are you writing?
I'm writing. Oh, you cannot see the whiteboard.
Yes.
Oh, sorry. I thought you were able to see the whiteboard. I thought I projected the whiteboard. Sorry for that. Can you see the whiteboard now?
Yes.
Yo.
Yeah, it's
Let's
visible.
go. 215.
230 and 235.
235 or 245.
35.
And then for the temperature, I think so. So it's
30.
30, 40, 40, 50, right?
Yes.
So give me the totals of each cell.
160.
160.6,
0.6. 161.3. 160.6. 160.4.
Help him, guys. Help
161.
him. Can someone do the last one for 50? Yes, continue, Christopher.
161.1.
Yes.
16.
Can someone give us the final one? Christopher, in the meantime, find the totals for the temperature. Can someone give me the last row?
161.2.
161.2. Thank you, CH.
161.7. And 160.5.
Thank you. Maleke, maybe you can continue giving us the total for the temperature. The totals for the temperature. Or someone can help you. We're only 10 guys. You must be jealous if we conclude without you saying something. Let's go.
I'm working on it, but the first one is 482.2.
Chris, how far?
484.1.
4.1. Let's go, guys. We're a team. We're only 10.
481.1.
The last one.
Yes.
And the grand total there, you can only add the totals from either the treatment or from the pressure. Let's continue.
The total
What's
is
happening with the other guys? Guys, let's go. We're a team here. If it was possible, we're even going to open our cameras. But I understand it's still
481.5.
still morning. Sorry?
481.5.
The first one, right?
So I'm getting 482.5.
Yes.
Oh, the first one.
Yes, I'm getting 482.
Oh, yeah.
Mtetwa?
Omitted the one. Yeah. I omitted the one. I omitted the 161.3.
Oh, he said 160.3.
Yeah.
It's fine. Thank you, Mtetwa. Thank
Yeah,
you, Mtetwa, for also the.
482.5.
Thank you very much, Mtetwa. And the team. Let's go.
481.5.
Let's go. I'm hearing, so far I managed to hear four
Four-
voices. I heard Mtetwa's
480.
voice. I heard CH's voice. I heard Chris' voice. Novela's voice. What is happening with the other guys? Can I hear your voice, please? This one is what?
483.4.
483.
483.4.
83.4. And the total? You can simply add the green ones, or the green ones is the same thing. You can just add these three.
1447.4.
1, 4, 4.
447.
What?
7.4.
So here we have our summary, guys. So I said you can say let, if you want, let temperature be what? Be A. And let pressure to be what? To be B. So that if you want to move with SSA, SSB, it will be fine. So when you solve this problem, someone can can move using this format: SS temperature, which will be the same as if someone said SS let temperature to be A. It will be the same as SSA. It means it's supposed to temperature. And then SS pressure, for someone who said to let, will be the same as SSB. So let's, now the temperature we know is on the what? It's on the column, it's on the rows. So I is 3. So our focus is on I now, because the temperature. This one right. I'm what is where the temperature is situated from 1 to what? From 1 to A, isn't it? So then here to be what? You divide everything by what we are not focusing on, which is what? Which is BR. Isn't it, guys? So you do the same with the other ones, and then we do the testing part. So SS minus Y dot squared divided by A, B, and R, because you have 3 dots there. So this will be, which values are we using? 482.5 squared plus 481.5 squared. Sometimes it's not necessary, guys, to show us this step. If you are able to capture the values from the question paper, don't write them like this. Just capture them from the question paper and then just indicate that I managed to get this. When I square the value totals for the treatment, this is the value. So I'll show you what I'm referring to. Squared divide by BR minus 1447.4 squared. Oh, this one is not visible. Let me write it. Let me know when it's time up. 1447 point. You said what? Like 0.4 squared. Divide by how many values do we have from the table? It means we have 3 by 3 by 2. So do this. So this solve this problem. So what I was saying is that you can try to get rid of this step. If you know what you are doing, you can even do it from the calculator. So what is the first part here? This one, BR. We can change the B because B is 3 multiplied by 2. R is 2. R is 2. So what is the first part, guys?
Zero comma 3011.
Is the final answer
Yes.
0 comma
3011.
3011? So you do the same with the what? With the pressure, right? Now you are focusing on the pressure. I want to emphasize how to deal with this new guy, SST. SS treatment, I said you'll be using the values from what? The values from each cell. I, J dot. This one, I think it has to be double summation. If it's having ij like that, let me check. Let me check the formula for the treatment. Yes, it's supposed to be double summation. Yes, I was right. I'm right. It's supposed to be double summation here because we have
So,
I and J. I from
sir,
1 to, yes.
so the SST for this chapter is like the SS model.
It's like the SS model. Yes, correct, Christoph. I explained it earlier. It's like the SS model that you covered with Mr. Levo. And because here, you know why what I'm looking for. While saying AB minus 1 is the degrees of freedom. Why are we saying that? Because remember, we managed to get this using what? Using the combinations. So what I want from you guys is, based on our example, this one, how many combinations do we have here? How many combinations do we have? Let's write them down. Let's write them down.
9.
How many?
9.
9, right? Let's write them, Chris. When the temperature is 30 and the pressure is 215, right? When the temperature is 30 and the pressure is 230, right? When the temperature is 30 and the pressure is 235. This is the first part. When the temperature is 40, but the pressure is 215, 40, the pressure is 215, 40, 235. The last one is 50, 215, 50, this one is 230, right? Sorry. And then the last one is 50, 235. When you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's true, it's 9. So let's check. Let's check with our degrees of freedom here. What is our A? Our A is equal to what? 3. Our B is equal to 3. 3 multiplied by 3, we're getting what? We're getting 9, isn't it? 9 is from here. It's from these combinations. When you count them, you say 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why we're saying AB minus 1. So when you less 1, you'll have what? You'll have 8. So that's how you find the degrees of freedom of treatment. That is why we say the degrees of freedom of treatment is AB minus 1. We're counting the number of what? Combinations that we have from the problem. Now, I indicated that for this SST, we'll be using what? We'll be using the values from each cell. The values you guys were giving me, you were saying up to what? Up to the last value from each cell, which is what? Which is 160.5. 160.5 squared. You divide by what? The number of replications from each cell, which is 2, minus 1447.4 squared. Divide by what? Divide by 3 by 3 by 2. So when you are writing a test or an exam, if you think this part is not necessary for you, you can even solve the problem looking at the values from the table. Just don't write it. Don't write it. Just write what? Just write the what you get after this part. What you get after this part. You can simply exclude this step. Because imagine if you have to transfer all those values to a script. It's time consuming. And your exam is only 2 hours. So please, let's find a way to get this thing right. So looking at the time and the load shedding thingy, let's go and finish the problem. And when we meet on Tuesday, we do the pairwise comparison for this section. And then maybe it will be possible for us to move to the other section. I thank you. Any question, leaders? Now the issue seems like load shedding just started now. Load shedding just started now. I think people are affected by load shedding now. So let's meet next week, Tuesday. I thank you.